Hey, thank you very much for joining and listening, everyone. My name is James Bailey. I'm the Head of Business Development at SubQuery. I'm based in New Zealand, so if you have trouble with my thick Kiwi accent, I apologize in advance. But I'm really happy to be talking to everyone today. Really happy to be here. Really happy to be joining the Polkadot North American Hackathon. I'm really good to see that Polkadot's doing all these hackathons, hopefully around the world from here on out. So it's really cool to see the next generation of applications come through, and we'd like to be a part of that at SubQuery. So today we're going to talk about Polkadot data indexing made easy with SubQuery. And so the first thing we always start with, and a lot of people ask us, is what the hell is data indexing? Why do we need data indexing? Why do we need SubQuery? And it really comes down to the problem. Okay, so the problem today, there's an agenda, but let's skip through this. The problem today is that querying decentralized data is a pain in the ass. It really sucks. Okay, so the way that data is stored on a blockchain is kind of like a book, where every 6 seconds in Polkadot's world, a new page is written. And that page includes everything that's happened in the previous 6 seconds. Now, if you want to go through your book and find all the characters and what pages they appear on, you have to go through each page sequentially. It's the same with blockchain. If you want to, for example, if you're building a wallet and you wanted to see a list of transactions that have been made to or from your account, you have to go through every block sequentially to be able to determine that list of transactions, to be able to collect that information. So in a way, blockchains are the most terrible way to store data if you want to be able to query them. They're a linked list. And in order to build increasingly complex and intuitive applications, which is what developers need to be able to do, they need tools like SubQuery to be able to process and query that data faster. So for those that here, and a lot of you guys are all technical, so you can understand that on Substrate, there are 3 different types of kind of things here. There are blocks, there are events, and there are extrinsics. And you can currently query those using Polkadot's API very easily. But unless you know exactly what block is the data at the point that you're looking for, unless you know exactly what extrinsic ID you're looking for, it doesn't really work like that. So one of the solutions that we try to bring through a SubQuery, and what SubQuery is all about, is about making that data more accessible. So it's an open source project that allows developers to index, to transform, and to query their Substrate chain data to power the applications. We talk to people all around the ecosystem. We work with many different customers, and many times have said to us, we're happy that we talked to you, and we're happy that we started using SubQuery because it literally saved weeks of development. And for teams like yourself that are working in the hackathon, saving days of development is critical in a hackathon. So it's kind of like Google for blockchain. And for a developer, it's like taking a linked list, a data set from a linked list, and putting it more into a spreadsheet or an actual database. It just makes it a lot more easier to deal with. So SubQuery is built with 3 things in mind. First, it's open. It's open source. It's completely flexible. And it's fast. So it's open source. You can do whatever you want. Think of SubQuery as like a scaffold. We build the tool, but you use and wield that tool to build the applications that you need and to build the data sets for you. It's flexible. So those data sets that you build are completely tailored to your application. You can customize those data sets to use in your application and to do different things than what your competition's doing. And it's fast. We really put a lot of effort into this. We focus on making SubQuery faster than others. We still try to keep things atomic, so all in one package. Other kind of projects will pre-process data, but we kind of keep it all in one place. But we have a lot of different methods, different hacks, different pre-computed indices and caches designed to make SubQuery fast. And indexing speed is really important. So we're already trusted by the best, right? You talk to all the explorers like Subscan, Subviz, .marketcap, they're all using us. One of our biggest use cases was crowd loan data last year as an example. Different dApps, lots of wallets, for example. Nova Wallet, Velas Wallet, Subwallet, and Metadot all use us. And many of the blockchain teams themselves, just to be able to understand their network, understand how things are going, and to build applications within their network. So many applications around the ecosystem, some of the biggest names you've heard of, already use and rely on SubQuery. So one of the leading players in this ecosystem. We've been around for a long time. We've talked to a lot of different teams. So let's kind of move on from this talking and let's kind of get into the nitty gritty and let's build a project live. So before we do that, there's three main things we're going to look at today. And this is how to build a project in a nutshell. It only takes about 10 minutes. And it's a set of instructions on how to index data. So that's really all SubQuery is. It's a recipe. You tell SubQuery that I want data from this place, I want it stored in this format, and SubQuery does the rest. And there's three main components. There's a GraphQL schema file, which is the shape of your data. There's a manifest file, which is the kind of configuration of your project. So where you're indexing from, what. And then there's mapping files, which are like the data pipes. So how do you get data from the Polkadot.js event or extrinsic or block into the format that you want? And that's the mapping file. So there are three main handler types, and this is the last thing we'll do before we jump into the code. Actually, I can explain this in code, actually. So let's jump over. I got VS Code here. I'm just going to create a brand new project, and I'm going to call it, we're going to index live here today, a very common example, but very straightforward. So what we're going to index today is about all the transfers. We want to index every single transfer that has ever happened on Polkadot. So I'm just going to initialize a new project using a CLI tool, so SubQuery init. It's going to ask me for Polkadot Hackathon. Excuse me, you can never type live. That's a problem. Now, SubQuery is multi-chain. We support Avalanche, we support Substrate, we support Terra, and we support all networks within Substrate. There's some examples that we can get from. I'm going to do a Polkadot one. I'm going to use the starter template. It's going to go off and grab that. I'm going to use the default RPC endpoint, so it requires an archive node. Just using Git repository, I won't bother any of those changes for now. I'm the author. Leave that description, leave the version number, leave the license, and I'm just going to cd into that project and just open up that in my VS Code. Okay. So here we are. We now have a project, okay? So as I said before, what we're going to do is index all transfer events on Polkadot. Very simple example, but very powerful. And in the background, I'm just going to do a yarn install because that always takes time, and it's time that I'm not talking to you. So there are three main mapping types. The first one here is a block handler. Now, this is saying to SubQuery on each and every block, we want to do something. And that's kind of really inefficient. It's not that good. It just is a very brute force approach. So avoid block handlers where possible. But it's there if you want it. The second one is an event handler. Now, we have this concept of events in Polkadot.js. So if you want a certain event that's emitted from your smart contract or whatever action that happens, you will emit events. Those are good examples of things to look for. So example, I want to index every deposit made on chain. I would look for that event from the balances module. And then finally, there's call handlers. These relate to the extrinsics, the extrinsic calls, and very similar events. They're also quite good. You can filter down very specifically what you want to index, and we'll only do those mapping functions on those things. So what that looks like here in SubQuery, we're going to build a project here. So I've set one up. I'm going to start, we always start, I'm going to start with my schema file. Now, a schema file is basically the shape of your data set. So I like to start with it because it kind of sets from the start what our direction is going to be. And as I said, we want to index all transactions that have occurred. So I'm going to rename this. This is a GraphQL schema. And you kind of think of this as like as defining a class or defining a database table where it's a transfer table, and these are your columns. Now, you always have to have ID as a required field, of course. I'm going to also index the amount, the sender, the receiver. I always spell receiver wrong. And I think now we're going to do block number as well. Now, the amount obviously isn't, it's a big int. The sender will just be a string, and that's your account address. We just do. Same with the receiver, it's a string. And the block number, of course, will be another big int. Okay, so I've got a new entity, and I'm going to use something called codegen. I'm going to codegen this into a bit more of a concrete type, and this will just happen in the background. So that's my final, what I'm trying to get. This is my output of my SubQuery project. I want to have every single transfer ever made mapped to this entity. The second file that we always look into is a project manifest. This is the configuration. And this has been set up from our configuration when we initialize the project from our default. We're connecting, there's a lot of like boilerplate stuff at the top here, like a description, your GitHub repository, your name. The main things are the network. I'm indexing Polkadot. Now, SubQuery supports off-the-shelf any Substrate network. So even if you're building your own custom network and you want to build a front end for it that we've never seen before, as long as that network, you can import the types, and we'll go put over that later on, SubQuery will work automatically with that. You don't have to build any pre-processes, you don't have to do any other work. It's just straight away will work. Let me just add someone else in. And then, so this is going to Polkadot. It's going to a Polkadot node run by Untitled. And it's using a dictionary, which is a pre-computed cache of all the locations of certain events. So it speeds up the SubQuery project quite a bit. Dictionary is a really good feature to add on. Now, where it gets important is down here. This is my handler types. I'm starting from the first block, and I've got all three types of handlers: a block handler, an event handler, and a call handler. Now, I'm just going to simplify this down. I don't need all this stuff right now. I don't need a block handler. All I'm looking for is transfer events. And the best way to do that is by looking for event handlers and just going for transfer events from the balances transfer. Now, you might ask, how do you know about that? How did you realize that's the name of the event? Well, it's quite easy. If you go to like something like Subscan, which I'm sure everyone here has used before, you can look up what you want. So I'm going to Polkadot. I want to look for transfers. And the way that transfers are mapped, they're actually mapped as, well, they've got this extrinsic as well, but you can map an event with balances transfer. So it's extrinsic, but I can also look for events. And I can look for the module, which is balances. And if I find transfer, and this is kind of what I'm indexing. And Subscan, Subscan uses SubQuery in some parts of the stack because, again, they just provide a UI in front of the indexer. So I want to index this kind of stuff. So I've got my manifest all set up here. The third and final file I'll edit is the mapping file. And again, this is that data pipeline. Now, the way that the mapping file works is it receives a block or an event or a call from the chain, either extrinsics, events, or substrate blocks, and then you can do whatever you want in there. So you can map that data into whatever other entities you want. You can retrieve data from any other endpoints around the world. You can go get price data from CoinGecko. You can make a request for the current weather. You could ask for what the star sign is or whatever. It doesn't matter. Like whatever happens inside this method here will be triggered every time one of those things happens. But you can do whatever you want. So for us, we just want to be very simple, right? We want to look for event handler because we're only looking at events. We're getting rid of all the block and extrinsic handlers. And you will see where this handle event correlates to this handle event. So every time something that matches this filter is found on the blockchain, then we will run this handler. So we need to edit this handler. And the first thing is we're going to import the new transfer we did. So when I did yarn codegen, I generated some types. And one of those types is this transfer type. And you'll recognize what I wrote here. We generated a proper TypeScript class from the GraphQL schema that I did. It has all these helper functions on it. Everything's typed out quite nicely to make life very easy. Okay, so handle event does something really simple. It will receive a substrate event. It will get the data off it, and it will save a new transfer event. So the way that we get data off this event is actually quite simple. So the data on a handle transfer event, and this is where Polkadot gets a little bit tricky. If you look at the view code, the way that this actually works is, let me just go into There's a bit more docs somewhere here. Let me just find the docs. So it's a bit tricky, and you can go into the Polkadot documentation, but the way that the payload is stored on this is within this like event, so substrate event data, and inside data there is a array, and you can see here this array has where is it? No, it's extrinsic, sorry. This array has three properties. It has an account ID, and a balance. And the way that there used to be like a way you can see documentation here, unfortunately. I don't know why it's showing up. It's not showing up. But the docs here, this would be the from, this would be the sender, the receiver, and the balance. So there's three properties within this array. So I'm going to like map this using this kind of thing, using this way to define that. So I've got sender, receiver, and amount. Okay, so this comes off the event payload. I'm then now going to go and create a new transfer event. So, const transfer equals new transfer. And I always have to initialize a transfer event with a ID, and the ID has to be unique. And the best way to do this is by using the event block number. It's doing the same way that Subscan uses. I'm just going to go to existing code and copy this because it'll be faster than typing it out myself. So the way that Subscan do it is they use the block height, and then they also add the event index on it, because the events themselves won't actually have a unique ID at this point. So they have the block height and the event index on that block. Then I'm going to, on my transfer event, I'm of course going to get and add the new, the from ID. So sender equals transfer.from .sender equals sender.toString. Same with oh, sorry. So amounts, all these things come off as codecs, and codecs make it really easy to like convert. Codecs are like a decoded version. You can kind of see them here in Subscan. One thing that we want to do is this codec is of a tight balance. So we can cast this to a tight balance. And the way that you do that is going amount as balance, and that imports that from Polkadot.js, the Polkadot type interfaces, and then go to big int. So that's how we get the correct value of that. We cast that to a balance. The rest of these are just strings, just regular strings. And then the final one, I think, is block height, right? We want to get that. Block number equals, obviously, the event number, and then it's to big int, not to number. Okay, and I'm going to save that transfer. Cool, that's it. That's how easy it is. I'm going to yarn build at the bottom here. I'm just going to run off and build this project, and I can start Docker. Docker is always really moody on my system, so let's hope it works. The way that you run is by running it with, you can run this in Docker in your local machine. Let me just get the right command. Docker compose pull, Docker compose up. And that will go and pull the Docker images, and it will start running this. And it will set three things up. So what I'll do is I'll set up an indexer, which is using our node service. It will connect to that Polkadot chain, and it will start indexing all the events that match this filter, and then run them through this mapping function. And it will save that in a brand new Postgres database. And that Postgres database will have the schema as we defined here. And then we'll also set up a brand new query service. And this query service will use a GraphQL endpoint. And the GraphQL endpoint, if you've ever used GraphQL is amazing. You can do heaps of stuff in it. You can make requests for any values. It's kind of like SQL, but safe to use over the internet. And while we wait for this to set up, the first run on Docker takes some time because it's a set up a Postgres database. We'll carry on back here. Actually, we should be able to kind of go through and run localhost. No, it still hasn't started yet. So I'll set up a query service. Oh, you might want to mute yourself. So this is all running in the background. This is a very simple project, but you can relate these. You can have foreign keys from the GraphQL. You can have like these mapping functions. You can like retrieve data from other places. You can update data. So lots of projects use us and have very complicated situations. Unfortunately, my port's reallocated. Why is my port already allocated? Let me just set up Docker Hub. I'll just run it from here and see if that works. We might not be okay to run this, unfortunately, my local, but I always have port issues on my laptop for some stupid reason. But yeah, you can run this yourself. It's open source. You can run on Docker. You can run it locally, individual services, and lots of customers do. But we're also providing managed service. And this is a managed service where customers can deploy their SubQuery project to our hosted environment for free. We'll run it for you for free. And we'll run that infrastructure for you. And you'll get a GraphQL endpoint that looks like this. This is our managed service. You can see many different projects, including Nova Wallet, Makala, a lot of NFT platforms. So really cool, projects from all over the place. And one of the problems is there's so many projects on this hosted service that we can't really go through and show them. There's a lot of like Nova ones for different parachains. Octopus is building some stuff. Suramitsu, many different projects. And you can go in here and you can try them out. You can like look at, okay, let's look at what users doing. And you can make queries for their data set. You can see what they're indexing. I think user are an NFT project on Moonbeam and building an NFT marketplace. You can make queries using the playground here. You can make queries using this API endpoint. And you can also actually look into their code. You can check out their code. You can see how they built it. And you could go and maybe extend it, improve it, fork it. And there's many examples of things that have already been built. So we have a managed service, which many customers use, and we're doing hundreds of millions of requests per day. So we're hitting a huge amount of scale, a ridiculous amount of scale. And we run it for a really high reliability, so you can really trust it, which is why you see all these big wallets are running on it. We're also building a decentralized network. So the guilty truth about all these centralized services like ourselves and blockchain is it's centralized, right? It's kind of a bit of an oxymoron where you're building a decentralized world and we've got these centralized services that these apps rely on. So we're building a decentralized version of SubQuery. And the whole point about this, the whole goal of the decentralized SubQuery network is the decentralized infrastructure part. So you can build a SubQuery project. You can put it out there to the network and you can ask someone else or a group of other people to index that data for you. And the SubQuery network will manage all the uptime, all the rewards for those people. It just allows you to offload all the infrastructure running in a decentralized way. We've just finished a testnet for that. We've got one more phase of our test network, but we basically, in our test network, simulated 200 million API requests in a single day. 200 million API requests in a single day to over 150 indexes in our test network. So that's launching soon, but your project, as long as it's written in a safe way, in a deterministic way, will be able to run on our decentralized network when it launches probably next quarter. So you can completely decentralize your infrastructure stack. It's going to be a huge step for us. But again, some other features I want to talk about, right? So we build the best fully featured indexer on Substrate and Polkadot so that you don't have to. Don't rebuild the wheel. There's no point trying things that have already been done before. Our entire focus as a team is on making this indexer faster, better, more reliable. And some of the new features are just added. I'll go through these lists. So the first one is accessing data on different Substrate chains. We support any and every Substrate chain. There's no data pre-processing required. All you have to do is bring in your types. And we provide examples of all these different types, over 40 different supported networks. You can get started straight away. But if you're building your own Substrate chain as part of this hackathon, and you want to do some analysis on it, or you want to build a UI on top of it, you can use SubQuery in a few minutes. Like you just have to import your types. And so for Kala, all that means is you just have to import their type definition overrides. We have documentation how to do this. But once you do that, you can build a SubQuery project like you would for Polkadot. It's that easy. We built it that way. We now support every single EVM on Substrate. So previously, we just supported the Frontier EVM implementation. So that was ones that used by Moonbeam, by Astar, and by quite a few other networks are implementing the parity Frontier EVM. But Akala's just released the EVM Plus solution, and we're just announcing support for that as well. So if you're building an Ethereum virtual machine or a smart contracts on EVM, SubQuery works for you as well. We're now building, we've released a feature that allows you to do GraphOL Subscriptions. Now, this allows you to build more responsive applications. And the way you do that is rather than having to poll the server for new data when something happens, you can subscribe to changes and update that in the UI as soon as it happens. So if you want to build a notification bot for something happening on chain, you can do that. If you want to build an application where you have like a buy now button for NFTs, and you can kind of like constantly monitor if that NFT has got sold, so you don't have like people clicking buy now and then they get pissed off because in the meantime that the NFT had been bought by another person, you can do that. And we now support GraphOL Subscriptions natively. This is a new feature, and it's quite a weird one. And we're doing a hackathon grant with Remark about it. So I'm really looking forward to see what comes up around it. But this is automated historical state tracking. So an example here is you can design a SubQuery project, common example, where you want to keep track of all the account balances for all the accounts on Polkadot. Okay? And you might find that Alice, she makes a transaction, she receives some DOT. On block 10, she had 15 DOT, but on block 23, she had 25 DOT. Okay? And if you're updating Alice's, so back to our project here, if you were updating Alice's entity by retrieving Alice's entity and saving that data back, you would have mutable data changes to that Alice's entity, and you'd be overriding that history. You can't. So what this automated historical state tracking does is it automatically captures and stores and tracks the historical state of all entities for all time. So you can go back in time to the 15th block 10, and you can see what the state of the entire ecosystem, all the balances that everyone in Polkadot had at that block, and that's automatic. You could do that before in a manual way, but this just does it automatically. And you can kind of query that. So, you can basically override the query. If you want to query an account, there's now a special method where you can add a block height, and you can ask for the state of that entity at that block height. Now, it'll be automatically supported for any new SubQuery project here on out. And existing projects will have to re-index to support it. But yeah, it's automated. It's all automatic. It's really cool. And we're looking forward to seeing what happens with that. And I'll talk about a Remark bounty that we're doing with them, particularly related to this one later. SubQuery is multi-chain. So obviously we support all Polkadot chains, all Substrate chains, including those that aren't connected to Polkadot, but are still built on SubQuery, Substrate, sorry. But we're expanding our support, and we're expecting to become an indexer that supports as many chains as possible. We have a goal of 6 chains to support by the end of this year, and we've announced 2 very recently. We announced Avalanche, which has got a huge community of developers. But it means that if you have plans to build something that's cross-chain, which, if you're in Polkadot, you believe in cross-chain. It's kind of like you can take that for granted here. So if you have plans to build for Avalanche, SubQuery is going to be there for you. We also announced support for Terra. Obviously, this was pretty bad timing for our part. We feel for what happened for the Terra ecosystem, for all the developers in there. There was a really tight-knit community of developers working around Terra. But we were looking at where we're going to support them next. So expect more announcements and more layer 1 chain support coming very soon. But we're furiously adding more and more chains here and now. But that just means that you as a builder, you can write one subquery project, and it's very minimal changes required to adapt that to another chain. Before I go to questions and answers, I'm just going to go back. Unfortunately, my Docker is just playing up on this computer, but you can generally run that yourself. What I'll do is set up a local host instance, and you'd be able to query that locally. But thankfully, I do actually have this project in the Explorer, so I can kind of show you what it looks like. So if I go to look for transfers, I can actually find my, no, that's a different one, transactions, I think. Yeah, this is my project, and I can actually go and index that. So I've got transfers, my transfers entity, and I can query the first 5. You can see this is fully indexed. It's synced. There's been a total of almost 10 million transactions or transfers that have happened on Polkadot. And I can ask for the first 5, ordered by block height or block number ascending. So what was the first 5 transactions that ever happened? And who were they from? And the first transaction that ever happened was actually on, it was on this block. It was on the 29,000th block. It was that amount of dot, and it was from that account to that account. I don't know whose accounts they were, but I imagine one of those is Gavin Wood's. You can also ask, what is the ordered by amount descending? I can look at this as the largest ever transaction ever made in Polkadot. I can add filters. I could say, give me the largest that this account has sent. So I could add a filter, which is, let me just put this next one, which is toID is equal to double bracket. And this will filter this to that address. So this is the largest ever transaction made to this account. So a big transaction. That's obviously a whale. You can do whatever you want, right? And so you can do this in this particular project. I've also got a foreign key, so I could do a join on this table. But GraphQL is quite advanced in terms of the features and functionalities you can do and the queries that you can make from your front end to get data. And this all just stems from this very basic schema that we defined here, right? And this very basic mapping handler that took no more than 10 minutes. That's how easy it is to use SubQuery to build the applications in the future. So we're going to record this and share this out. But if anyone here is listening has any questions, feel free to speak up. Otherwise, the best place to talk to me is obviously, I'm being a mentor, so you can probably book some time with me to talk through anything, to ask for a bit more questions, maybe ask some advice. I can point you in the direction of some example projects or some other projects by other teams that might do something similar to what you want to do. What I do want to do before we finish is go through the grants and bounties that we have. Now, obviously, we have one of the largest bounties. We did a 4-way bounty with Moonbeam, Akala, HydroDX for 20,000. And that was a cross-chain messaging UI tool. It's a really interesting bounty. It's a really big one. But it's a really critical application that's needed. And you can definitely use SubQuery to index any cross-chain messaging. You'll have a look at some of these workshops that we did with Moonbeam, some other documentation. There's another bounty that did some work on it. So there's a lot of other pieces here that will help you working on it. You can see Team NZ is working on it. But that's a really cool bounty out there, really large one that has supported quite a few different teams in Polkadot because of how critical it is. So really happy to work with them. Additionally, we're doing this really cool one from Remark for this time-based NFT Explorer. Now, Remark is an NFT platform. They have an NFT marketplace, but they want an analysis tool, where you can see things about the individual NFTs or collections. You can see all the basic stuff like the floor price, the ceiling price, the current number in each connection, the current state, the owner, all the same similar stuff. But the tricky thing here they want to do, or something that's not that tricky thanks to SubQuery, is they want to have this kind of idea of a scrubber on the bottom, almost like a progress bar that you can click and drag, and you can drag it back in time and see how that NFT changed over time. So what state was it back at this block? Who owned it back then? What was the selling price for this collection back then? And so you can see the history of a remark-based NFT. You can see how they changed over time, how they evolved and flourished. That's what they're looking for. And that automated historical indexing, that feature I just showed you, that will basically solve all your problems with this. All you have to do is focus on indexing the key data and building the UI around it. So really cool bounty there with remark. That should be pretty straightforward to do. We're also looking at some WASM contract support with Gear, some liquidation tools on Akala's stablecoins with Akala. So a monitoring tool that whenever the AUSD, KUSD comes at risk of liquidation, it will send maybe a bot message or have a UI to make that easy that you can then liquidate some of your Akala for a profit. And of course, some cross-chain indexing challenges. So we have a lot of different challenges in the hackathon and a lot of different opportunities. But regardless, even if the challenge isn't here that you're working on, if you're working on one of the more general challenges, SubQuery is one of those foundational tools that could make your life a lot easier. So even if you're not working on one of these, if you're building an application, if you need a UI for your data, it's very likely that SubQuery will save you a lot of time or make your life a lot easier. And make sure you check it out. But feel free to reach out and make contact with us, make contact with me as a mentor, ask any questions in our Discord. We really much look forward to working with you and to seeing what's created. That project I just made, there's an example there on that GitHub. So you can see what it was like, try it yourself. But thank you very much for listening. Thank you very much for your time, and good luck out there hacking.